In this video, we're going to work example problems related to radian measure. So what are radians? What exactly is a radian? And how do we convert from radians to degrees or from degrees to radians? Okay, an angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the blank of the circle has measure 1 radian. So you've got a circle, and then it's saying that there's an angle that has its vertex at the center of the circle, and this angle, which is this, it has a measure of 1 radian. This angle, we can put it anywhere. So it's saying this angle is 1 radian, and it intercepts an arc on the circle. So if this angle is 1 radian, then how long is this arc? Well, that's 1 radius. So equal in length to the radius of the circle. Okay, 360 degrees is equal to how many radians? And 180 degrees is equal to how many radians? Well, you should know this off the top of your head. This is the typical conversion factors you'll use to convert between degrees and radians or radians and degrees, either one of these. But a full rotation, how many radians is a full rotation? It's 2 pi radians. Okay, what about a half of a rotation? Well, here, let's just divide both sides of this equation by 2. 360 divided by 2 is 180. What's 2 pi divided by 2? Pi. To convert to radians, multiply a degree measure by blank radian and simplify. To convert to radians, so if we've got a degree measure, how do we convert to radians? We use the conversion factor. I like this conversion factor. You have 360 degrees for every 2 pi radians. Degrees cancel, and you're left with radians. So you can simplify the 2, so pi over 180. To convert to degrees, multiply a radian measure by blank and simplify. So it's the same thing. You use the exact same conversion factor, but if you've got something in radians, an angle in radians, then you do this. 360 degrees for every 2 pi radians. And now the radians cancel, you're left with degrees. So 180 over pi. Each angle theta is an integer when measured in radians. Give the radian measure of the angle. So, okay, each angle theta is an integer when measured in radians. Give the radian measure of the angle. The reason why this question could be a little counterintuitive is because when we think about like degree measure, it's easy to think about integers, 1 degree, 2 degrees, 3 degrees. But when you think about radian measure, it's hard to think of it as an integer because it's so related to pi. Pi is the opposite of an integer, right? It's an irrational number. So radians are inherently like they're not really integers. They're integers in the sense that they're, multiples of pi, like 1 pi, 2 pi. You can think of it that way, but if you kind of like actually represent it as an actual number, like without take pi out of it, you don't think of it as an integer. That's why this could be counterintuitive. And I think that's why there could be like a disconnect with a lot of people between the definition of radians and using radians. Because the definition of radians does think you are talking in integers, 1 radius, 2 radiuses, 3 radiuses. But then when you actually look at the numbers, it involves pi, which is not that intuitive as far as thinking in terms of integers. So, okay, how do we answer this question? If theta is going to be an integer, then let's think about this, okay? How many integer, going from 0 to 2 pi, how many integers are there? Okay, pi is 3.14, so 2 times 3.14, like 6 point something. So there's 6 integer values. Going from 0 to 2 pi, you have 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians. Okay, now if we think about pi over 2, so 3.14 divided by 2, 3 divided by 2 is 1.5. So pi over 2 is a little bit bigger than 1.5. 1.5 radians. So there you go. You're going to go from 0 radians to an integer 1 somewhere, like greater than 45 degrees. So this is going to be 1. This has to be 1 because once you get to 2 radians, you're going to be in the second quadrant. So this is 1 radian. And again, you don't have to put RAD, radians are unitless, but it's personal preference. If you want to put radians, you can, or you could just put 1. You could put the angle with no units. But with degrees, you have to put degrees. You couldn't, if this was 1 degree, I couldn't do this. This would be implying radians. I have to put degrees, but I could leave it like that, and that implies radians. That's fine. Or you could put this or this. Okay, so this looks like it's going to be 2 radians, but let's see where's 3 radians. So 3 radians is right like pi. This is pi 3.14 radians, close to 3.14. So the integer 3 radians is like close to here, right above pi. So this isn't going to be 3. This is not close enough to the x-axis. So this is going to be 2 radians. And this is going to be 3. Okay. So it seems like we went from 3 and then skipped 4 and then went to 5. But, okay, so this is 3. And we have 3 more integers, 4, 5, and 6. So is just 4 in the third quadrant and 5 and 6 are in the second? Or is 4 and 5 in the third quadrant and just 6 in the second? Seems like it's going to be 5 and 6 are going to be in the second. So, okay, this is 3 pi over 2. So 1.5 times 3.14, 4.71. Yeah, so you just have the integer 4 radians is in the third quadrant, and then 5 and 6 is in the fourth quadrant. Now, I'm assuming that n is equal to 6 is going to be, yeah, with 6, with the fact that 2 pi is 6.2 something, then n is equal to 6 is going to be close to the horizontal. So this is going to be n is equal to 5, or 5 radians. Oh, well, wait, no. This is a negative angle. Okay, that's not right. Did I mess these up before? Okay, those are all right. Now, okay, this is not 5 radians because we're going in this direction. So, okay, but this is 5 radians. So that means that, well, no, it's not. This is not 5 radians because theta is an integer. Because if this was 5 radians, then I was thinking that, okay, well, this would be 6 radians, but that's not right. Because that implies that a full rotation about the circle is 6 radians. That's not the case. So this would be 1. This is going to have to be negative 1. Because we saw that you go from here, this was 1 radian, and then you get to like 2 radians here. So this has to be either 1 or 2. It can't be more than for sure, right? Well, we know this is going to be negative 1 or maybe negative 2, but negative 2 is going to be over here. So that's negative 1. Okay, now this is going to be negative 2, or no, negative 3, because this was 3, right? Why? Because the negative pi is negative. This is negative 3.14, so this is right below that. This is negative 3, and this is going to be negative 2, for the exact same reason that this was 1 radian, this was 2 radians. But now we're just going in the opposite direction. 1 radian, or negative 1 radian, negative 2 radians. Okay, convert each degree measure to radians. Leave answers as multiples of pi. Okay, these are really easy. If you want to convert from degrees to radians or radians to degrees, the key is you just need to know what's the conversion factor, which should be easy to memorize. Once you have the conversion factor, you're set to go in either direction. So the conversion factor, it's not like you have to know how many radians are in 1 degree or how many degrees are in 1 radian. That's one way to think about a conversion factor, but it can be any relation. Like if you know that there's if you have this many degrees, this group of degrees, that equals this group of radians, that's fine too. So we know that in a full rotation, there's 360 degrees, and in the same full rotation, there's 2 pi radians. There's your conversion factor. Once you have this, you can go either direction. Because, okay, 60 degrees times there's 360 degrees and 2 pi radians. The degrees cancel. What unit are you in? You're in radians now. That's what you're looking for. So now just multiply this out to get the value. So that's pi over 3 radians. You can either do this, or you could leave it with no units. That's fine. You can leave a radian measure unitless. You cannot do that with something like degrees because degrees is not a unitless. It's not unitless. Okay, 90 degrees. There are 360 degrees for every 2 pi radians. Or you could use the fact that there's pi radians and for every 180 degrees, a half rotation. So the degrees cancel and you're left with radians, pi over 2. Okay, 150 degrees. I'll start using pi radians. In a half rotation, there's pi radians for every 180 degrees. Degrees cancel. (15 divided by 3 is 5. 18 divided by 3 is 6. 5 pi over 6. This is equal to 5 pi over 6 radians. Okay, negative 300 degrees. There are 180 degrees for every pi radians. Yeah, when you're doing a bunch of these back to back to back, I guess it's easier to use the 180 to pi conversion factor because then you don't have to simplify that 2 every time. But I like convert the 2 pi to 360 because I think about the full rotation, and then but in practice you're not doing 30 conversions like this. You just do it every now and then whenever you need it. So it's not that big of a deal to cancel the 2 in that case. And to me, it's easier to memorize that full rotation is 2 pi and it's 360. But yeah, here going through these problems, I guess you'd rather have that 2 already canceled. Okay, so the degrees cancel. Okay, 30 divided by 2 is 15. 18 divided by 2 is 9. 15 divided by 3 is 5. Minus 5 pi over 3. And you could leave off the radian unit here, but to me here you'd want to put it. You don't have to, but you want to put it because you're showing, you're showing you've gone from this to this. But it's personal preference. Okay, 450 degrees. There are 180 degrees for every pi radians. 45 divided by 9 is 5. 18 divided by 9 is 2. (180 divided by 18 is 10. 18 divided by 18, so this is 10 pi. Okay, 0 degrees is equal to 0 radians. But you could do the conversion factor, 0 degrees (0 times pi over 180, 0. Okay, minus 900. This is degrees. Degrees cancel. 90 divided by 9 is 10. 18 divided by 9 is 2. 10 divided by 2, so minus 5 pi. Okay, now let's go the other direction. Let's convert this radian angle measure to degrees. So this is just a number, right? They don't even put radians. That's fine. It's just a number. But in this context, we know we're talking about angles, so that means this implies radians. Okay, but again, it doesn't matter the direction you're going, same thing. Pi over 3 radians, okay? There's 180 degrees. Now you put degrees up top because you want the units to cancel for every for every pi radian. Those cancel and you're left with degrees. That's what you're looking for. So just do you get pi's cancel. 180 divided by 3 is 60 degrees. Now you have to put degrees. So yeah, that's not so bad. I guess you could have left off we could have left off radians before in the previous problems. You know, it's personal preference. It's all acceptable. You can put radians, RAD, the word radians, or leave it off. Okay, there are 180 degrees. Radians cancel. The pi's cancel. Okay. So 7 over 4 times 180. So this is 4 divided by 180 is 45. 45 times 7 is 315. So this is 315 degrees. Okay, 11 pi over 6 radians times pi radians for every 180 degrees. The pi's cancel, so we've got 11 over 6 times 180. 6 times 3 is 18, so this is 30. 30 times 11 is, so 30 times 10 is 300, plus another 30, 330, so 330 degrees. Okay, minus pi over 6 radians times pi radians for every 180 degrees. So this is minus 30 degrees. Okay. 7 pi over 10 radians times the fact that there are pi radians for every 180 degrees. Okay, so 7 over 10 times 180. 10 divided by 10 is 1. 180 divided by 10 is 18. So 18 times 7. 8 times 7 is 56. 7 plus 5 is 12. So 126. Okay. Minus 4 pi over 15 radians times the fact that you've got pi radians for every 180 degrees. Okay, so we've got minus 4 over 15 times 180. So 15 divided by 3 is 5. 180 divided by 3 is 60. 60 divided by 5 is 12. 12 times minus 4 is minus 48. Okay, you know, at this point, this is just, you know, do you know how to multiply fractions more than trigonometry, right? So this in radians, and then 180 degrees for every pi radians. You know, It's like, can we multiply these numbers? So 17 over 20 times 180. So this is going to be 9, and then 17 times 9. 9 times 7 is 63. 9 plus 6 is 15, so 153 degrees. Okay, minus 5 pi. Pi radians. And the radians cancel. So 180 times 5. 900. Minus 900. Okay, convert each degree measure to radians. If applicable, round to the nearest thousandth. So we want to convert 42.5 degrees to radians. Okay, well, what do we do here? Same thing. Nothing's changed. It's just now it's just a more precise degree measurement. Exact same thing. 42.5 degrees. We want this in radians. There's 180 degrees for every pi radians. The degrees cancel. We're left with radians. We just need to do the multiplication and round to the nearest thousandth. That's it. So 42.5 times pi divided by 180. There you go. So they want it 0.742 radians. Okay, convert 139 degrees 10 minutes to radians. Well, how do we do this? Well, no, this is 10 minutes just means a fraction of a degree. This is like 139 point something degrees. So, okay, what fraction of a degree is 10 minutes? There's 60 minutes in a degree. So 1/6. This is 139 and 1/6 degree. Let's make that a just one fraction. So 139 times 6 plus 1, so 835/6 degrees. That's what this is, 835/6 degrees. So we want to convert that to radians. Well, 180 degrees. For every pi radians, the degrees cancel, and there you go. Now just multiply all this out. So 835/6 times pi over 180. Okay, but we need this. We want to round this to the nearest, or it said thousandth of a radian. So 2.429 radians. That's it. 64.29 degrees times the fact that you've got 180 degrees, or we could say 360 degrees and 2 pi radians, whatever. Doesn't matter. Degrees cancel, and you've got 64.29 times pi divided by 180, 1.122 radians. This is 1.122 radians, which makes sense when we think back to problems we did earlier in the video. This was like 1 radian. This was, or no, this was like 2 radians, something like that. So yeah, this is like right where 64 would be, somewhere around in here. I probably drew this a little bit too steep. 1 radian's around here, so 64 is kind of around here. That's right around where 1 point, we're not that close to 2 radians, right? We're just past 1. So this makes sense. 56 degrees, 25 minutes. So how many what fraction of a degree is 25 minutes? There's 60 minutes in a degree. So 25 divided by 5 is 5. 60 divided by 5 is 12. So 5/12. This is 56 and 5/12 degrees. Okay, let's convert that to a so 677 twelfths. Okay, so now, I mean, you don't have to do this. I just think it's easier to think about doing the multiplication. You could leave it like this if you want to convert 5/12 to a decimal. 180 degrees for every pi radians. So 677 twelfths times pi over 180. .985 degrees. Okay, minus 47.69. There's 180 degrees for every pi radians. Degrees cancel. So what is, let's do the minus 47.69 divided by 180 minus 0.265 radians. And here I put degrees. This is radians. Okay, now let's convert these radian measures to degrees. These are like decimal radians, but same thing. So 1.74 radians. You've got pi radians for every 180 degrees. The radians cancel. They want the answers to the nearest minute. Okay, so 1.74 times 180 divided by pi. So 99.6947 degrees. All right, but they want us to convert this fraction of a degree to minutes, to the nearest minute. Now, in chapter 1, we did practice converting something like this to minutes, to degrees and minutes. But here, let's do it a slightly different way since we're practicing with conversion factors. So the idea is we know we're going to have 99. This is going to be 99 degrees. And then, but we want to, instead of having point whatever, we want to have minutes to represent this fraction of a degree here. That's the idea. So what we're trying to do is convert 0.6947 degrees to minutes, right? So we're trying to convert it. So what's a conversion factor for degrees to minutes? Well, we know there's 60 minutes for every 1 degree. So if we want to convert 0.6947 degrees to minutes, how can we do that? Well, there's 1 degree for every 60 minutes. So 60 times 0.6947. So 41.682 minutes. But they just want the answer rounded to the nearest minute. So rounding this to the nearest minute, we round this. 42 minutes. So 99 degrees, 42 minutes. So 1.74 radians is 99 degrees, 42 minutes. Okay, 2 radians. We want to convert that to degrees. So there are pi radians for every 180 degrees. So now we're in degrees. We just need to do the multiplication. So, oh, nope, got to put degrees. So, okay, 2 times 180 divided by pi. It's going to give us an exact answer there, so we need to 114.592 degrees. Okay, so we've got, this is 114 degrees and then some amount of minutes. How many minutes is 0.592 degrees? There are 60 minutes for every 1 degree. $35.52 minutes. Round that to the nearest minute, that's 36 minutes. So 114 degrees, 36 minutes. Okay, 0.3417 radians. It doesn't specify any units, but that's okay. You can do that for radians. But I want to specify here because I think about crossing out the radians. So there are pi radians for every 180 degrees. So 0.3417 times 180 divided by pi, 19.578. Degrees, but how many? This is going to be 19 degrees in a certain amount of minutes. How many minutes is 0.578 degrees? Like we could convert 19.578 to minutes. We would do this and then have 1 degree is 60 minutes. What would happen if we did that? Well, we'd get this big number of minutes that's greater than 60. You don't report something in minutes that's greater than 60 because there's degrees in there. So if we did that, then what we would do is divide by 60 and see how many, and take the degrees out, the whole degrees. Okay. So 1 degree, 60 minutes. Degrees cancel. $34.68 minutes. Round that to the nearest minute, 35 minutes. So 0.3417 radians is 19 degrees, 35 minutes. Okay, minus 5.01095 radians. There are pi radians for every 180 degrees. So minus 5.01095 times 180 divided by pi, minus 287.106 degrees. So that's going to be minus 287 degrees in a certain amount of minutes. 0.106 degrees is how many minutes? $6.36. Round that to the nearest minute, so 6 minutes. So this is